Assalamu alaikum and good morning again. Today we are going to look into the use of starter in DC motor. Okay, let us consider when the machine is start up from rest, in which EA is equal to 0 because omega is equal to 0. The start up current IA is going to be equal to VT over RA. What is the value of this start up current? Let's consider motor parameter that we have used before in our previous examples, where RA is equals to 0.1 and the terminal voltage is around 100 volts. So therefore IA is going to be equal to 1000 ampere. And this is very large because for typical machines that we used in the previous example, the rated current is only at 120 ampere. So 1000 is several times larger than the rated current, and this very huge current can cause damage to the machine. Therefore, we have to find ways in order to reduce this start-up current from damaging the DC motor. So how do we limit this large start-up current? In general, there are two ways we can do that. The first is to control the terminal voltage VT using the variable power supply, for example using the power electronics converter. In order to limit the current, we need to increase the terminal voltage VT gradually from 0, which means that we are not applying step voltage of 100 volts to the terminal voltage, but rather we increase it gradually. And as we increase it gradually, then the back EMF voltage will build up as the speed builds up. Therefore, the current will not become very large at start up. What if we don't have that variable power supply? Because normally, variable power supply is very expensive. An alternative way is to add an external resistor to the armature circuit, which is known as the starter. With the external resistor added to the circuit, then the total armature resistance is going to be equal to RA plus RST. Therefore, at start up, when EA is equal to 0, the current is going to be equal to VT over RA plus RST, which is not going to be as large as before because of the higher resistance due to the external resistor RST. As the speed builds up, so too is going to be EA, the back EMF. And in order to avoid the high losses I square R due to the external resistor RST or the starter resistor, then we have to gradually reduce RST. Let us look on how the starter works. This is the starter resistance. It has a wiper with 4 positions 1, 2, 3 and 4. In position 1, the wiper resistance RST is going to be maximum. As the wiper moves to position 2 and 3, the values of the starter resistance reduces. When the wiper is at position 4, the value of the starter resistance is 0. We know that the armature current is given by VT minus EA over the total resistance, which is the sums of the armature resistance winding and the starter resistance RST. Let's see how the armature current, the speed and the back EMF change as we change the positions of the wiper from 1 to 4. Initially the positions of the wiper will be at position 1. The speed of the motor will increase from 0, so too is the back EMF EA. And according to the equations of the armature current, as EA increases, the current will reduce. When the current reaches the minimum value I mean, the position of the wiper is changed to 2. When the wiper is at position 2, the value of RST is such that the armature current gives the maximum values of Imax. The speed will further increase, so too is the back EMF EA, and according to the armature current equations, the current will reduce as EA increases. When the current reaches the minimum value I mean, we change the positions of the wiper to 3, and the current increase to a value Imax again, which means that the values of RST when the wiper is at position 3 is calculated such that the armature current gives the maximum value Imax. The speed and the back EMF will increase, and again, as the back EMF increases, the armature current reduces. When the armature current reduces to I mean, we finally change the positions to 4. The speed increases, the back EMF increases to a steady state value, and so too is the current. The armature current will reduce to the steady state value as shown in the graph. As you can see that the armature current is limited within the range of Imax and I mean by gradually changing the positions of the wiper from 1 to 4. At each positions of the wiper, the values of RST has to be calculated such that the armature current is within the values of I mean and Imax. This is one example of a practical starter circuit. This diagram is taken from your textbooks PC San. It consists of a handle with resistors R1, R2, R3 and R4 connected in series with the armature circuit. As the handle moves from position 1 to 2, 3, 4 and 5, the values of the resistance in the armature circuit reduces. The electromagnet here is used to hold the handle at position 5. This is another example of the starter circuit. In this circuit, there are 6 resistors which are connected in series with the armature. As the handle or arm, as shown here, is moved to the different position, the values of the armature resistance will change. Again, the electromagnet here is to hold the handle or arm in the final position. When it is in the final positions, the starter resistance is 0. The overload trip here is used to protect the DC motor. When the current becomes too high, the electromagnet will pull the overload trip bar, therefore shorting the electromagnet that hold the arm in the final position. The spring will therefore pull the arm, hence disconnecting the armature circuit. We will now do example 4.10.